Hey there, AppSec engineers. Welcome to this video series on application security. In particular, we will be discussing command injection attacks in Node.js applications. Did you know that in 2021, a critical command injection vulnerability in Homebrew's GitHub Actions workflow allowed potential supply chain attacks affecting millions of macOS and Linux users? In that case, a branch name was used to format an inline script. While this incident was caught before exploitation, similar vulnerabilities continue to plague web applications today. In fact, command injection attacks have contributed to over 25% of critical CVEs in web applications in recent years. So, what is command injection? Command injection vulnerabilities occur when applications execute system commands using unsanitized user input. Today, we'll examine a real-world example in a Node.js application, understand why it's dangerous, and implement proper defenses to prevent such attacks. Here's why you should care. 78% of Node.js applications use child process methods unsafely. The average cost of a successful command injection attack is estimated at around $170,000. Let's switch to our hands-on labs to take a look. Before diving into the attack, let us take a look at the application code and understand what it is trying to do. In this case, we see that we're looking at an Express application, and it seems to respond to the ping endpoint by pinging a certain host. In this case, an IP address will be pinged when this endpoint is hit. In this case, you will notice three major vulnerabilities. The first on line 12, where the constant host is being set using the request directly. This is a case of direct user input usage. Next, on line number 13, we have an attempt at poor input validation. The second vulnerability is the use of insufficient validation. We're only checking for ampersand and semicolon. However, this misses other shell operators such as pipe, $, or backticks, etc. Further, there is no validation for the IP address format, either using regex or otherwise. And finally, we are not whitelisting, which would be the most powerful way to validate any user input. The third and the most serious vulnerability can be found on line number 15. We see some string templating in action. This is unsafe because we're directly interpolating user input. There is no parameter separation, nor is there any escaping or sanitization of the user input. Finally, we're using the method execSync instead of safer alternatives such as spawn. This is bad because synchronous execution blocks event loops. And finally, shell interpretation is always enabled by default for execSync. Now that we understand that, let us take a look at how the attack would work on an application like this. Let me pull up my terminal. We now have the application running. With the application running, let us showcase normal operation. So what we're sending here is a post request on the endpoint that the application is running on, and we are sending it an IP address to ping. In this case, this is just localhost. And we see that the application is able to give us information about the IP address. To showcase the command injection vulnerability, let us use the pipe command, which is not included in the very bare bones validation that we are doing in our application. You will see that we're bypassing input validation using the pipe operator. And there you go, you now have successful command injection. Let's try a slightly more malicious attack this time. What we've done is we've queried the etc password file, and we're able to list out all the users on this particular machine. This simple attack just revealed our application is running as root, and we could also read sensitive system files, in this case the password file. Further, because we have shell access, we can modify application data, install malware, or pivot to other systems within the network. This of course sounds very dangerous. So what can we do to prevent something like this? Let's talk about defense. Taking the defense in depth approach, let us go back to all the three vulnerabilities that we saw and try to add a much more robust way of handling things. To begin with, we could replace execSync with a much more benign version called spawn. So let me make that first change. And therefore, instead of using execSync, I will now use the spawn command. Next, we spoke about improper input validation. So let us add the validator library that allows us to do this in a much more robust fashion. In this case, we're using the validator library to ensure that the user input is either an IP address or a fully qualified domain name. Next, we can replace this entire block with a better way of constructing the shell process. What we're able to do now is use the spawn command to separate the arguments from the command itself, thereby preventing injection. This is possible because parameters are passed as array elements and not through string interpolation. Finally, let us introduce a more fine-grained method of error control. In this case, we are taking the event-based approach to handling errors, allowing us to respond in a much more granular fashion. Let's go ahead and test this application and verify that we have achieved what we are looking for. Let me save this and run the application again. With the application running once more, let us try the same payloads as last time. First, to verify that the application is running as intended, we send it the usual post request and receive the same as last time. However, if I now try to exploit the pipe operator as I did last time, I hit the validator, which confirms that this is neither an IP address nor a host address. Similarly, an attempt to read the shadow file also results in hitting the validator and being stopped. Our security improvements work because 1. The spawn method separates commands from arguments, preventing injection. 2. The validator ensures that the input is actually an IP address or a domain name. 3. Parameters are passed as array elements and not through string interpolation. And 4. Event-based handling provides better error control. Some key takeaways from this. In closing, never trust user input. And wherever possible, always try to use safer alternatives such as spawn when using the child process instead of exec or exec-sync. And remember to always implement proper input validation because that is always your first line of defense. Remember to separate commands from your parameters, thereby reducing all chance of injection. Finally, always follow the principle of least privilege. Thanks, and I'll catch you in the next one.